Hello, dear students. In the previous lecture of our chapter Structure of Atom, we have already studied the Thomson model. That is your watermelon model, you can call. Okay? We have already discussed. Now today we are going to discuss Rutherford's atomic model. The second model is given by the Rutherford here. And when Rutherford is given the model, at that time proton as well as electron, both particles are known to exist in nature. Neutron is still not discovered at that time. So, one more thing you must know about the Rutherford, that Rutherford atomic model is an experiment, mean to say practical. While three models we are discussing in this chapter. First one we discussed Thomson, which is theoretical, mean to say he didn't do any practical, but Rutherford did a practical. That practical is known as famously alpha scattering experiment. It is known as alpha scattering experiment, famously known. So this is the only model which is practical based. So let's start this particularly. What is the alpha scattering experiment? First of all, he took a radioactive element. Radioactive element is dear like lead, heavy metals, plutonium, uranium, any metals you can take here, which is radioactive. Radioactive means to say it emit radiation. Okay, alpha radiation. Three type of radiation are released: alpha, beta, gamma. Which alpha have two positive charge, beta have negative, and gamma have zero charge. But alpha radiations when emitted, he extracted the alpha radiation and he made to fall alpha radiation on a gold foil, very thin gold foil. He taken a gold foil off in front of them and he bombarded the alpha particles on them. Okay, so what he observed when he fall the alpha particles on the gold foil. So he made some observations. So in case of the practical, there is no assumptions or postulates. In case of practical elements, there are observations. So what are the observations? He said, first observation, mostly alpha particles, or you can say alpha radiations, passed straight through the gold foil. Even he is saying that almost 90% radiation straight passed through the gold foil. Straight. Second observation what he made in the practical, that a few radiations get bent to slight and large angles. Mean to say some radiation bent to a slight angles and some are bent to a larger angle from the gold foil. This is the second observation. Now the third, a rare mean to say almost 99.9% is almost bent, but only 0.1% radiation get bounced back, or you can say reflected back. Completely goes straight and then comes back, that is reflected back, but very rare particle. These three observations he made particularly on his alpha scattering experiment. And now on those observations made, he gives conclusions. So what are the conclusions regarding Rutherford atomic model? He said that mostly alpha radiation passed straight through the, almost 90% radiation passed through the gold foil. That's why almost space in the atom is empty. Almost space in the atom is empty because almost radiation passed. From the second observation, that a few radiation get bent slightly to large angles and small angles. So he concluded on that base that there is positive charge in atom which reflect, or you can say repel alpha particles. There is some positive charge inside the atom, because that's why the alpha particles get bent. But on third observation, he said that a rare particle get reflected back, which proves that all positive charge is located in the center of the atom, which he called nucleus of atom. So Rutherford is the one who discovered the nucleus of the atom first. Okay. So on these observations and its conclusion based, if you draw the structure particularly, so the structure will come in this manner, that there is a nucleus which created positive charge and atoms are spherical and electrons are surrounding this nucleus particularly here. Okay. So this is the atomic model given by the Rutherford observation. But it has also limitation dear at last. This one also have limitations. What limitation? That atom stability, or you can also call matter stability, because matter is made up of atoms. Atom stability is not explained still. Why? Because why these electrons, if they are negative charge, why they are not moving towards the nucleus and neutralize the positive charge, and atom should collapse. And matter should also collapse. But atom is stable, matter is also stable. But it means atom stability is not explained by its structure. Second thing, I told you about the spectrum. Spectrum is not explained by him as well. Spectrum is not explained still by him. But he gives a little bit more advantage as compared to the Thomson model, because in Thomson model there is no nucleus known to come in existence, but in Rutherford model we very well get known that there is a nucleus inside the atom which carry all the positive charge. Okay, so today we have completed our Rutherford model. I have told you that in Rutherford model is a practical model, that's why you have to do observations, conclusions given by him, and at last his limitation. These three things you need to discuss about or you must know about the Rutherford's atomic model. So today we are going to do only Rutherford models. Tomorrow we will start about the next atomic model which gives the structure, is Bohr atomic model, which is a theoretical model. Okay. So today first thing you will do, read the topic we did, or you can say Rutherford model. Second, make your notes there in fair notebook. Third, solve blueprint questions and answer in rough notebook. Okay. Thank you.